Today we're going to be working with trying to find the slope of a line, but from a line that is graphed out. So the line will be on a graph, and we want to be able to try and find out what the slope of that line is when you are given a graphed line. In the past, we've used 2 points that were found on a line, but we were not given a graph, and we were able to use the slope formula in order to find the slope. Now we will do the exact same thing, which is finding the slope, but we're going to be using a given line. Now on this line, you will see 2 points that are given to you, and you'll be able to use those points if you are more comfortable using the slope formula, but I am going to show you what you can do in order to find the slope of the line. But before we start, there's a few things that we want to look at, and I'm just going to do a rough sketch of some graphs. So if we had a line, let's say it's graphed and it goes from left, and you always want to determine the slope of the line traveling left to right. That can let you determine if it's going to be positive or negative and so on. So if you have a graph that travels up as you go left to right, and again, this is not an accurate graph, it's just what we have. So anytime that you have a graph, as you travel from left to right, almost pretend like you are walking up the graph. It's a terrible drawing of a man walking up a graph, but he's walking up an incline. So that slope is a positive slope. So anytime you see the line going from left to right, and it travels up, that is a positive slope. Now let's look at another example. We have a line that travels from left to right, but this time the line goes down. Well, anytime that you have a graph that goes from, there's my terrible picture of a man skiing, as you travel from left to right and it goes down, well, that is a negative slope. So a negative slope will travel down as you go from left to right. And if you're not too sure, pick a point on the line, pick another point in the line, and if the second point is below the first point, again, you have to go from left to right, and the second point is below the first point, you have a negative slope. Now, there will be some problems that you get to that will have lines that may be a little bit hard to figure out. So let's say you have a line and you go from left to right. It does not go up, it does not go down. It's almost like it's a flat surface. Going left to right. And as you travel from left to right, it does not go up, it does not go down, but it does go left to right. Well, you can determine this has no slope, and some people call it zero slope. So no slope, zero slope as you travel left to right. And finally, you'll see lines like this that may not make any sense when they go from left to right. It's straight up and down. So it doesn't really go left to right, it just goes up and down. Points are over top of each other, and you cannot determine if it goes up or down because it doesn't travel left or right. And of course, if you had somebody like this, they are falling as they go. So as you can see, you're not traveling left to right, the person is falling. Well, this slope is undefined. You cannot define the slope because it doesn't travel left to right. So those are the 3 things that we are looking for today. So we're going to actually find the slope, and we will be able to tell if they are a positive slope, a negative slope, no slope, or even undefined. The good thing is, when you have a positive and negative slope, you will actually have a fraction or a whole number depending how the slope is written. If there is no slope, it's a flat line, you'll just have to put the word the number 0, or put 0 slope. And if the line travels up and down, it does not go left to right, you will know that it is undefined. So those are the 4 type of answers that you will have. Just remember, if it's a positive or negative slope, you will have to write the negative or positive fraction that goes along with it. So let's look at some examples from the work that I'm doing with my class today. It just says find the slope of the line. Now, when you have the slope of a line like is given here, you can see that they have 2 points for us. Now, you could take those 2 points, where the first point is at -4, 0, and the second point is at 1, -1. We could use that, use our slope formula to find it, or we can do just a little bit of a different look to it. So what you want to do, you're going to go traveling from left to right, and you know your answer is going to be a fraction. And we know from looking at this graph, from traveling left to right, that this line goes down. So we know the answer to this is going to be a negative slope. Now, what we also want to be able to determine is the rise over the run. Remember, slope is rise over the run. How much does it go up and down? And the run is how much does it go left and right. So what you can do from the first point, the very first point, you can take a line and do a vertical line all the way through that first point. Then you go to the second point, and if they don't give you a point, you can just find anywhere on the graph where it crosses on its own. But from the second line, or second point, you can do a line that is horizontal. And where they meet, right here, will determine, basically you will count to that spot or from that spot in order to find the rise and the run. So we first want to determine how far up and down do we go. So we're going to start at our original point, and we're going to go down 1 unit. So we see that we travel down 1 unit. So the rise is actually -1, but we knew it was negative already because it goes down as you travel left to right. So it's -1 is the rise. Now the run, as you travel from left to right, again, we are going to start at the point that we have, and we see it goes over 1, 2, 3, 4 units. So that's a +4. So we know that the slope of this line is -1/4. Again, how did we do that? We do a vertical line at the furthest left point. We do a horizontal line at the furthest right point. Where they meet is what we will count to. And if we have to go down in our first step, we will know it's a negative slope. And again, if it travels down as you go from left to right, you know you have a negative slope. So look at the next one. Now, this is one of those situations where we have 2 points. However, we don't have any horizontal lines that can work. So if we did an up and down or a vertical line at the first point and a horizontal line at the next point, well, if we counted from the 2 points, we see that we go down 1, 2, 3. We went down 3. However, we did not go left or right. So the left to right, or the run, is 0. Now, if we would write that as a fraction, that would be -3/0. But knowing how fractions work, knowing how math works, and knowing how division works, you can never have a denominator that is 0. You can never divide by 0. So just going back to what we realized at the beginning, if you ever have a line that is straight up and down and it does not travel left to right, we know that this slope is undefined. So this is an undefined slope. So let's continue to go left and right. I'm going to zigzag through this paper so you can see what we're doing. So now we do have a line that travels from left to right, and once again we see as it travels from left to right, this one goes down. So we know right off the bat it's not going to be a 0 slope because it went down. It's not going to be undefined because it travels left to right. So we know that our answer will be negative. Once again, vertical line at the furthest left point given to us, horizontal line at the furthest right point that's given to us, and we can now find the rise and the run to where they meet right there. So we can see that we had to go down 1, 2, so we went down 2, and we went right 1, 2, right 2. So we have -2/2. Now, we know that when we have a fraction that's -2/2, we can simplify that so it becomes 2 divided by 2 is 1, so it will be -1 is the slope. Now, -1 could be the slope. Some people may want it to be -1/1, so you can identify the rise and the run, but when you have the same number on top and bottom, you know that you will have a slope of 1. In this case, it went down 1 to right 2, so it's a -1 slope, or -1/1. Going to the next one, we see that we have a graph as we travel. Now, it looks like it's almost straight up and down, but it's not. This graph is actually a positive slope. So we know in our answer that our slope is going to be positive. So you don't have to put a plus sign in front of a positive slope. You just know that it's positive. So the furthest left point that they give us, we're going to put our vertical line. The furthest right point that they give us is horizontal, and please excuse my crooked lines. And so as we can determine that they see that they meet here, so our first is we want to find the rise. How far up does it go? And it goes 1, 2, 3, 4, 5, 6, 7. So it goes up 7 and right 1, 2. So our rise is 7, our run is 2, and you want to leave this as a improper fraction, so we have 7/2, and that is our slope. No more that we need to do. That won't reduce. 2, there's no common number that will go into both 2 and 7 next to the number 1, so the slope of this line is 7/2. Next line we have is a positive slope. We know that it's positive because as it travels from left to right, the line goes up. So we want to again go for the furthest left, and you want to go to the vertical line. Furthest right point, horizontal line, and we see that they meet here. So we need to first find our rise, and our rise is 1, 2, 3, 4. Our rise is 4. Our run is 1, 2, 3, 4, 5, 6. So our rise is 4, our run is 6, so our slope is 4/6. However, we are not finished because we can simplify this fraction. So we know that the number that will go into both 4 and 6, the largest number that will go into both 4 and 6, since they're both even, is 2. So if we divide both the numerator and the denominator by 2, you would find out that the slope of this line is actually 2/3. 4 divided by 2 is 2. That's our rise. 6 divided by 2 is 3. That is our run. 2/3 is our slope. Last line that we're going to go over is here. We see that it is a negative slope. How do we know that it is a negative slope? And we started from the left and we traveled right. We see that it went down. So that is a negative slope. Horizontal line at the first point. Vertical line at the second point. We see where the two lines meet, so we can now count to see what our rise and our run is. We go down 1, 2, 3, down 3, right 1, 2, 3, 4, 5, 6. So we know we went down 3. So the negative's already there. So the rise is down 3, -3/6. However, once again, like our last problem, we see that this is a fraction that we can simplify. What's the largest number that will go into both 3 and 6? Well, we know that it's the number 3. So we'll divide 3 by 3 and 6 by 3. Now, we already know our slope is going to be negative, so that won't change. 3 divided by 3 is 1. 6 divided by 3 is 2. So the slope of this line is down 1, right 2. Hopefully that makes sense to you, and you understand how you can find the slope of a line now from a graph that is given to you.